Good morning, good afternoon, or good evening, depending on where you are, and welcome to the Nautel webinar on the new NT series, and specifically about our new 1 kilowatt NT1. I'm Chuck Kelly, and I'm very glad to be with each and every one of you today. Thank you so much for taking time on your busy schedule to be joining us. I'm Director of Sales here at Nautel. Joining me today is Mr. Rob Edsall, research technologist and one of the engineers here that's been most involved with our television product. Good morning, Rob, or good afternoon, Rob.
Chuck.
Nice to have you with us.
Thank you.
It's exciting to be talking about the Nautel NT series. We've taken it in a very short period of time from the 150 watt to the 250 watt to the 500 watt, and now the 1 kilowatt, which we introduced at IBC in Amsterdam a couple of weeks ago. But is actually going to begin making deliveries in April. So that's very exciting to see how quickly things are moving. Here's the things we're going to talk about today. We're going to talk about just generally the NT series in an introduction. We're going to talk about the specifics of the NT1, and we're actually going to go into a bit of detail, since this is a new product, and give you a better idea of how the NT1 is put together, what comprises it, and we're going to talk a little bit about Opti power, which is the PA-PR algorithm that both improves MER and improves efficiency. We're going to go in live for a tour of an AUI and of an advanced user interface via the web of a live transmitter that's here in the building. And then we're going to take your questions. And as always in our webinars, you have on your GoToWebinar application the ability to type in questions, and you can do that at any time. From the very beginning of the webinar, you can be typing one in right now. It won't bother anything. And when we get to the end of the webinar in a half hour or so, Rob and I will look at all the questions and do our very best to answer them. If by chance we miss your question, or there's too many to take during the time of the webinar, we will reply offline, since we happen to know your email address since you signed up for this webinar. So what is the NT series? Well, the NT series is a best-of-breed design. No one company knows it all, and we certainly don't. So we took the best modulator in the world, who we happen to think is a Danish company called Pro Television. We took some state-of-the-art amplifier designs from a company in Korea that we work very closely with, have worked with very closely for 40 years as our representative in Korea, and have sold 1,400 television transmitters in their own right. And then we combined all that with the Nautel AUI, the support and service, but the complete AUI that people who know our AM and FM transmitters are very familiar with. So combined, we have decades of experience, and it has created an innovative, cost-effective product that advances the state-of-the-art in television transmission significantly. And it's not just my word in saying that. It's also TV Technology, who awarded us the Best of Show for the only television transmitter manufacturer to be awarded that at this year's NAB. And last year, Broadcast Engineering was kind enough to pick us as the pick hit for the NAB show last year. So we're quite proud of all of that, obviously. Let's talk a little bit about the specifics of what the NT series are. The very first transmitters we introduced was the NT150 and the NT250. The common features of those boxes are that all of these transmitters come with most everything that other companies charge extra for or don't even offer at all. So for instance, all of these transmitters, all the NT series comes equipped standard with linear and nonlinear adaptive pre-correction. They all include the Nautel award-winning AUI and a very, very broad range of inputs, including ASI, SMPTE 310, over BNC, and then TSOIP, or the TS signal over Internet Protocol, either in gigabit Ethernet or in some models. At the moment, it's a 100 megabit Ethernet. And there's also the possibility of an optional off-air receiver in the ATSC mode. Another thing that's standard with all these transmitters is an integral critical mask filter. Other companies will sell transmitters that have relaxed masks, and we just decided that every single unit that would go out of here would be very kind to the adjacent channels and not step all over them, and all of them would have integral critical mask filters. We also, the Pro Television modulator that we talked about, it handles all the video systems. So you can do ISDBT, you can do ISDBT-B, DVB-TB, or DVB-T, or DVB-T2, or ATSC. And then we introduced, a few months ago, the NT500, which has all of the above, but also, and this is incorrect up here, I should have said with the included mask filter, so it does include the mask filter. It also includes the spectrum analyzer and Opti power, and that is available as standard in the NT500 and as a software option in the 150 and 250. Then we talk about the specifics of these amplifiers. All of these transmitters use LDMOS amplifiers. In all the current FM transmitters we're now making at Nautel, we're all using LDMOS amplifiers, whether it's the GB series or the NV Lite series or even the VS2.5. Those transmitters are all using LDMOS amplifiers, and the reason for that is very, very clear and very obvious. They have the highest efficiency by a long way, and they also have excellent performance, particularly in situations where we're dealing with a lot of amplitude variation. So the linearity of them is excellent and can be excellent, and that helps a lot, not only in, for instance, FM HD radio applications, but also specifically in this television application where maximum linearity is paramount. And so these amplifiers are very similar in design to the types of things that we're using on the FM side. We also have some high efficiency switch mode power supplies that are made by GE and just are excellent supplies. The AC to DC efficiency is outstanding. They have a broad range of input power, and in fact, this input power range is broader than this. These supplies have now been improved to be able to allow us to go down to about 90 volts at a partial power capability. So this is an important thing. If you get into a brownout situation, your transmitter's got your back. But I think the most important thing about these power supplies is how reliable they've been. We just had very, very few issues in the industry, neither in the thousands that we've shipped in the GB series or the NV Lite series, or the ones that have gone into the NT transmitters that we now have in the field around the world. We have an integrated software-defined modulator, which is upgradable in the field as the DTV standards evolve. I'll explain more about that in the future or later in the webinar. And high stability crystal oscillator with an input for an external GPS. In fact, it's actually an input for an external GPS antenna, not a receiver. The actual receiver is already built and included in the transmitter. So that's another thing I should change in my PowerPoint presentation for the next time. So let's take a look, Rob, into the NT series. We have, as I mentioned, this happens to be a 500 here, and we have these GE lineage power supplies, and they provide us 50 volts. So this DC to DC converter, what purpose does that have?
Well, that provides us with all our low voltage power supplies for the computer boards.
And also for the modulator.
Correct.
Yep, so all the other voltages, the big supplies that are actually on the AC mains, only provide 50 volts. And everything else is derived in this DC to DC converter.
That's right.
Then we have this controller board. What's on that, Rob?
The controller board is an 8-bit AVR processor, and it's monitoring the modulator and the filters and so on.
Mm-hmm.
It's also driving a front panel LCD display,
which we'll see in a second. Yep.
Yep.
Okay. And then the AUI card sits on top of that.
It does, and
right.
That's right.
Okay, and then there's this interface card here that's labeled as GPS inputs, but it does ever so much more than that. It's really the interface card to the modulator in large part. And that's also where there's some level changing going on and all that sort of thing. And then there's this modulator card, which is the plug-in card from Pro Television in Denmark.
Yes.
And these two cables here are bringing back the feedback from the pre-correction, both the linear and the non-linear feedback coming from directional couplers is fed back into the modulator, and that then corrects the signal and maximizes the performance of the signal. Okay. Then we can lift that up. We can lift that segment up, and we can see underneath that the lineage power supplies and a power supply distribution board.
Right. There's 3 lineage supplies in the 500, and they're sharing the current load.
Which is kind of nice because you can still stay on the air if you lose one.
That's correct.
Yep. And then we can look at the other side where the PAs are. Now, it normally doesn't look like this. There's covers over all of this stuff. So it looks like a lot of little silver boxes on one big honking heatsink. And so you've got the combiner in the middle. You've got 4 LD-MOS power amplifiers. These power amplifiers are rated, as I understand, at 800 watts, but we use 4 of them for 500 watts. So that's because of linearity requirements. And you have a directional coupler. You've got the IPA and the PA. So basically the signal coming from the modulator is coming down here and feeding into that, and then this is coming over to the IPA splitter and then broken out to those individual PAs.
Right.
Okay, and this is looking from the back, showing how all this goes together. Again, this is the 500 watt, but there's a reason I want to show you this in the 1 kilowatt presentation, and we're about to get to it. So these are the options that are available. As I mentioned, there's an off-air optional receiver for translators or gap fill applications. And that receiver at the moment is only available for ATSC. There's spare parts kits, surge protectors, and toroid kits, as is normal for Nautel products. Now we get to the payload. Finally, we get to talk about the new product. The new NT1 is basically comprised of 3 cabinets, and each of them is 4RU. And the top cabinet has in it the modulator that we just saw, the IPA and splitter, the controller and the AUI host, and the combiner. And then the bottom 2 are basically 500 watt, like NT500s, but minus the modulator and the IPA and the splitter and all that sort of thing. They do have some control because they're talking to those PAs, but we'll explain more about that in the future. But they're basically like the NT500. And looking at the rear, again, the top is the modulator, IPA splitter, controller, AUI host, and combiner, and the bottom 2 are PAs. And what happens is the output of the IPA is split into 2 ports, and they come over here at these 2 BNCs here, and they feed down into here and into here. And then those signals are amplified up to 500 watts, actually in excess of 500 watts, because there's combiner losses and low-pass filter and mask filter losses. Right. And then they are then fed back into these 2 ports from these. So there's a cable there, and there's another cable here. And those are then combined within the unit, and it comes out here. Now, there is something called a CAN bus, which is the interconnection between these 3 that allow them to talk and show the meters on what's going on in the different PAs and things like that up on the AUI, and that's done with these Ethernet connections down here. So they just daisy chain. So this one from here to here, and this one from here to here, and then you have that's the CAN bus. Now let's zoom in a little bit closer on the back of the top box and see how you interface that. So here we have the RF output monitor. There's those 2 inputs we were talking about and the 2 outputs we were talking about. But I should say these are the signals to the input of the PAs, and these are the 2 inputs from the PAs and the output from the PA. But then looking across at other things here, you've got the gigabit, megabit Ethernet input here. You've got GPS signals all over here. You've got the TS stream inputs, either SMPTE 310 or ASI inputs, which are configurable here and here. Then we have over here is the Ethernet, which is for the AUI. Here's the parallel remote controls. So you can have, for instance, a Burke remote control or site controls of some kind, the AC power connector, and the circuit breaker. Now, the AC power connector on this box is relatively small. The PAs have a larger power connector, which I can show you here, going back to here. So that's what takes the higher current in those 500 watt amplifiers. So you feed power to each of the individual cabinets independently. Then we got a block diagram. Now, Rob, I'm going to need a lot of help here. So we've got the RF input going to the receiver here. That's where the receiver card is. And then we have the modulator, which in this case we call the exciter board. And that actually has lots of connections to this motherboard. And that motherboard then connects to the outside world. And then we have an IPA with some level adjustment possible there to adjust the input level to the PAs accurately, right?
Yes.
And it comes out of that and goes into this splitter, which is a 2-port splitter, balanced splitter, has its own reject load here, and it feeds those 2 external cabinets. And those 2 external cabinets are, and that was actually, I misspoke. Those cabinets are each capable of 800 watts, but we run them at 500.
That's right.
And then we have our controller down here with the AUI host sitting on top of it, driving that front panel LCD. And then we have our power supplies and the DC to DC converter, which provides the 5 volts, 12 volts, 24 volts, and minus 12 volts, in addition to the 48 volts, which is going to all the PAs and things like that.
Fans.
Yep. And then we have feedback signals for linear and nonlinear pre-correction up here. Coming back, let's look at the other half of that block diagram, which is here. So there's the individual 4 PAs, the 4 LDMOS amplifiers in each of the 2 bottom cabinets, and they are combined together, and there's an output coupler here, and there's a monitor point. And then we have a 2-port hybrid combiner with a reject load, and we actually monitor the power going to the reject load so that we know if we've had a problem in one of our PAs that is unbalancing the power. We have a detector, and that signal can go back for the non-linear pre-correction. And then we have it feeding the mask filter, and then there is a feedback after that, a directional coupler here, which feeds back for the linear.
For the linear.
That's right. And then there's in some frequencies, the mask filter has some harmonic performance, it has some harmonic issues,
yes.
And so it's necessary to have an external low-pass filter. But that's a single, that's not a tuned device. That's for the entire UHF band type of thing. So, all right, and this is an idea of the NT series specifications. And of course, this is subject to change, but it does show you the general size and weight and efficiencies and frequency ranges, and the fact that both the 500 and the 1 kilowatt are available in single or 3-phase, whereas the lower power products are single phase only. So that should explain that. And we have brochures available on our website if you'd like to download and see those brochures. This is a little bit more detail on the optional receiver. So this just basically has a connector here. You hook up to an antenna, 75 ohm connector, like a TV antenna from Radio Shack or wherever, and it's synthesized. It's under control of the AUI. You can adjust the frequency of the receiver, and then it will tell you how much signal to noise ratio it's seeing and things like that. And then it feeds the output signal of this is basically an ASI signal, I believe, which then a TS stream that then goes into the transmitter and modulates the transmitter just as if you'd provided an external input. It's just all in one, so it makes it a translator. And then let's talk a little bit about the Pro Television modulator. This is an exceptional box. These guys in Denmark really have their act together. They've been doing modulators for years and years and years, and they're basically very, very high-powered computers on a single board. A lot of DSP power, tons of research and development into the software. There's just no way that we could duplicate what they've done. And as well, having all of the different systems available. But the thing that we really liked about this technology from Pro Television is that it is basically software defined, and that's important because the world is not, it is not just one FM system around the world. There's 4 or 5 basic systems, maybe even 6 actually. So there's the North American standard of ATSC. There's the DVB-T, which has basically been a European standard, but it's expanded far beyond that. The DVB-T standard. There's now the DVB-T2 standard, which is now in many countries that are implementing DVB-T or have implemented DVB-T. They're actually switching to DVB-T2, which is really difficult for some of them, because in many cases the modulator itself has to be taken out of service and gotten rid of.
And receiver issues as well.
The receiver issues, but then in addition, the requirements on the PA can be very stringent. And unless, if you had a system that was designed, for instance, for DVB-T, and you switched to 2, even the PA may not be compatible because it may not have sufficient linearity. So this is why, even at very low power levels, why this organization has invested so much time and money into making sure that this unit has exceptional linearity and flexibility, so that we can adopt standards and adapt to standards which are at the moment unknown. And that's a very complicated thing. So the other thing is the ISDBT standard. There's a Japanese ISDBT standard, and then there's the Brazilian variant, which is ISDBT-B, and that's in the use in the Philippines and in Brazil and much of Latin America. So, and then there's a totally different system, which we don't at the moment support, in China, and we don't support that one. And then these gray countries have yet to implement anything at all, or even indicate necessarily what direction they're going. The other thing that's on the horizon is something called Future of Broadcast Television. If you're interested in this, Google FOB-TV. And basically it's an association, an alliance of all these different organizations on the screen. Interesting to note that you have Japanese organizations, you have Korean organizations, you have European organizations, you have American organizations, you have South American organizations, with all who today have different standards. And yet there is an effort going on to try to standardize a world or global standard. And part of the thinking process, and you'll see this on their website, is that there are many people that believe that the broadcasting industry is competing in a larger sense with the telephone industry, the cellular telephony industry. And I can take my 3G phone and go anywhere in the world, and it still works. And you can't do that with digital television, and there are people that believe that's actually a hindrance towards the long-term success of television. So that's why this standard is being discussed. That's why this organization exists. And the question is, as broadcasters, you're about to invest in some technology, invest in some equipment. You want to make sure that it's future compatible. So we've done everything we can to make sure these products are capable of being upgraded with just a software upgrade in the future. That's why that's important. OptiPower. OptiPower is an algorithm offered as an option by Pro Television, which is basically a very, very advanced, very, very sophisticated PA/PR algorithm. Those of you who know the Nautel PA/PR system that we have that improves the HD power boost in our transmitters, it's very similar to what OptiPower does. OptiPower takes the amplifier and maximizes the average power, the RMS power, while keeping the peaks within the peak amplifier capability, thus improving both the MER and the average power capability of the transmitter. And this is how it was tested. So we took a transmitter where the peaks were just basically hitting the maximum in the transmitter, and we raised the gain by 50%. We increased the drive to the PAs, but we did it in the modulator through the OptiPower algorithm. The MER increased from 26.4 dB to 34.3 dB, and the efficiency improved by about 10 to 15%. It's pretty impressive, and it's a lot of calculations. If you think about it for a second, about the number of, if you think about the rotating vectors that are a part of a multiple carrier COFDM or OFDM system or whatever, you have to calculate the instantaneous position of all those vectors additively and then figure out what time and which vector you want to minimize a little bit in order to make it still fit the power capability within the transmitter. The calculations just staggers my mind. I mean, I grew up when we still had slide rules in college, and this kind of computational power is beyond my comprehension. but it does have value and it does work and it makes a difference. I mentioned that we have critical mask filters. This is just a little bit to talk about the performance of these mask filters. The ATSC mask filter looks like this, and you get, when you get the transmitter, you get drawings like this that show you how the transmitter works. And here's the same thing in DVB-T2. Most people think DVB-T2 is one of the harder standards to filter. So this is quite an aggressive filter. You can see we're down 25 dB minimum at the carrier frequency plus or minus 6 megahertz. That's pretty cool. And it works. And it's got a VSWR of 1.15 and an insertion loss of a dB. Pretty impressive. And that's all included in the price of the transmitter. Now we get into the fun stuff. This is where we get to test drive a Nautel transmitter. The Nautel AUI that we've worked so hard on in the AM and the FM products has been brought to the television product line because our customers who have hundreds, literally hundreds, of our AM and FM transmitters came to us and said, you know what, we've really gotten kind of hooked on the AUI, and we'd like to have it on our television transmitters too, so please go away and do that. Made our day in a sense. I mean, there's no higher compliment, but on the other hand, that's a lot of work. Anyway, we've done it, and it's been done, and let me show you what it looks like. If I can make this work here. There. This is a transmitter. Shall I turn it on, Rob? Is it okay to go ahead and turn it on? All right. So I hit the RF power button, and the explosion has happened now over in the engineering lab. The smoke is rising. We've got it set for a preset power of 75 watts, so it's coming up to 75 watts. So you'll notice it looks a lot like a Nautel AM or FM transmitter in that the top bar still holds your power level and your frequency and preset and the reflected power. And over here we've put in there what is the source. So the source in this case is the TS source input A, and the shoulders, which are the signals either at this side and that side, are measuring 61.5 and 62.4 dB respectively. If you're a very knowledgeable person about the television business, you'll raise your eyebrows and say that's pretty good. And then down here the MER is running at 40 dB, which is truly outstanding. Down here we have, this is a 250 watt transmitter, but we have installed Opti power, and therefore we have the spectrum analyzer built into the transmitter, and you can see the actual real-time performance of this transmitter, both as an RF spectrum, which is the green trace, but also as the MER, which is the red trace. And just like our AM and FM transmitters, on the right-hand side you've got all the meters, and we can choose what meters we want to be in there by coming over here and click on here, and then we can click which ones we want to select and things like that. We can also look at all these things at one time like that. And these are, if you look carefully, and I realize there's small letters there, folks, sorry about that, but you'll notice that they're changing and they're being updated dynamically. I can also come over and do that on the Exciter one. So you can see a lot of information, more information probably than you can see on most people's transmitters already. So that's one of the things we do on these transmitters. Now let's come to the center area. It didn't really make sense to have the various tools like we have in the AM and FM transmitters in this center area. So what we decided to do is to take the AUI, there's an actual AUI that's built into the Pro Television card, and embed that within our transmitter. So all of this is coming from this Pro Television card, and here's a mimic panel from the Pro Television card showing that the input A is green, input B, there's no signal on it, and the switching is coming over here. I have dragged and dropped this segment over to here, and now I have all of the information about the status of the inputs over here. If I wanted to look at the codec information, I could drag it over here, and now I can see the codec information, or I could look at the information about 8VSB, because this is an 8VSB system. And you can see the information there. I could also drag any of these green boxes. I can go drag them into these areas and make configuration changes, make other kinds of changes in the transmitter. Then when I come over here, I have the inputs showing the both nonlinear and linear inputs are within the tolerable frequency or amplitude range. Yep, and they're coming back in, so they're coming into the adaptive pre-correction. And we have this filter. That's a pretty linear, nonlinear pre-corrector showing how it's working. And then over here we have the RF output, which is showing the output frequency, and a lot of other details. So all of that is built in to that. Anything else I should show on this page, Rob? Pretty much gone through it all, so we can bring this back and have all that. Now let's go to the other AUI menus and show you what else is possible here. So we have presets, just like we have in our transmitters. And we can set the frequency by preset, the output power. We can have a scheduler. There's a built-in scheduler on this, and it's basically to the extent of changing power settings or something like that. You really wouldn't want to change frequency in so much because you have the output filter. Now, if you happen to have one of those systems in which your combiner is doing the filtering, the mask filtering, then it is possible that you could have a transmitter which is working and changing frequencies on the fly, depending on what frequency it's commanded to. You can do whatever else. The transmitter itself is completely broadbanded. There are no adjustments within the amplifiers or the combiners for that sort of thing. So that's the presets menu. We come down here to the menu here. We can also look at system settings. And basically we can reboot it or we can upgrade the software. Software on these things, even including the modulator and the CPU1 card, that is the basic settings of the controller of the transmitter, are all upgradable remotely through files that we can send over the internet. And you can select upgrade files and sorts of things like that here. We go back to the menu. Go to user accounts. Now you can create multiple user accounts in this transmitter. One thing that I didn't mention any other place was SNMP. The transmitter is capable of being controlled and monitored by SNMP, and so you can have an SNMP a user that can log in. But you can also have various different categories of users. For instance, if I add a user here, I can say Chuck. And do that, and then I have the ability to select what I can do. Am I a view only? Am I an administrator? I have full control. An administrator, the difference between full control and an administrator is an administrator could actually create other accounts. And you can have custom, and in custom you can actually give various permissions. Do you want the operator who's keeping the log to be able to turn the transmitter off? These kinds of things can be set in that fashion, so we can have all of that. And then we have user settings. And here's where we set up your IP configuration, your gateway, your name server, port numbers. All of that can be set up here. We also have, as we do in the other Nautel transmitters with an AUI, we also have the capability of having the transmitter generate an email. So if something, some setting, it goes outside of tolerance, you can specify who you want to send an email to. And if it's something else, for instance, you may have a situation where the VSWR on the antenna goes high. You might want to generate an email to a particular person who is the tower guy. But you could also have one that is there's a invalid input coming in on the ASI input. You may want to generate something that goes to one of the studio engineers or somebody who's responsible for the STL. And that sort of thing. So you can do all of that. That's all configurable here. You can change notifications and add things to the list of selected alarms, and then put the notification name and the recipient's emails there. So that's all just as it is in the other Nautel transmitters. So that's user settings. You can also specify the call sign or ID. I just filled that in with NT250, and that shows up here. So if you happen to have 20 or 30 transmitters, you can put in site names or call signs or what have you, so you're not mistaking which one you're looking at. Rob, we also have the logs here. So here are the logs that have happened today. You've turned it on and off a couple of times, and it's logged all of those things. It's told you about the specifics of the situation, what happened, what severity it was, what time it happened at. We also have a log manager where we can take a log that could have, for instance, thousands of entries going back months and months, and we can select a range of things. We can fine-tune what we're looking.
Right,
we can filter them.
Filter those logs.
Yep, and we can filter them by date or by type. And what's really cool, I love this feature, you can hit the copy logs feed. And what has just happened is that log these 5 lines on this previous page here have been copied to my clipboard on this notebook that I'm using on my desk here at a remote distance from the transmitter. And if I opened up Excel right now and hit Control-V or paste, they would all just paste in the log. So theoretically, I could have hundreds or thousands of log entries, fill them up into either Word or Excel, and have them all done that way very accurately with all the fields at a distance. So it's a very powerful tool. Any other things I should talk about here? How about this remote local? Would you like to talk about that at all, Rob? Or so basically the concept is, go ahead.
Yeah, well, a local, if somebody working on the system at a transmitter site would put this machine into local as a safety feature.
Yeah, you don't want somebody remotely turning the transmitter on while you got your hands inside of it.
That's exactly right.
So basically, this gives you the capability of setting the local or the remote mode. And when you're in remote mode, then from a distance you can control the transmitter, but not if you've got it set to local control only. Okay, so let's tab back to our presentation here and continue on. Let me see if I did that right one more time. There it is. Okay. And what you might ask yourself, okay, this looks like a nice transmitter, but why buy it from Nautel? Well, basically the concept is that over 45 years, we've built an excellent relationship with so many key customers around the world who happen to have both radio and television facilities. And many of the customers have asked us to get into the TV business because they've appreciated the way that we've maintained their AM and FM transmitters. They appreciate the creativity and level of support that they've become used to with our radio transmitters. And in addition, frankly, there's a number of customers around the world that have become hooked on the AUI. They love the user interface, and they'd like to have that level of monitoring and control in their transmitters. And so they've asked us to get into the television business, and Nautel believes that you ignore your customers like that at your own peril. So here we are. We're in this business now. And just like our AM and FM transmitters, we offer a 4-year warranty with all the NT series transmitters, and Nautel has never discontinued support on any product ever. And I guess that's a little bit more important these days. You know, there's a wind of fear, I think, in the television industry at the moment about a number of television transmitters that are no more. You know, the transmitters that people paid good money for and expected long lives are now orphans because these companies haven't survived. And so to a certain extent, a lot of the customers that look to Nautel, one of the things they really value about us is our stability and the strength of our organization. And that's all I'm going to say about that. So to kind of wrap up a little bit, the Nautel NT series is capable of ATSC, the U.S. and Canadian digital TV standard, DVB-T and DVB-T2 standard in most of the world, ISDVT, the Brazilian version, as well as the Filipino version, and the native ISDVT Japanese version. All the transmitters are supplied with critical masks. They are capable of both SFN, repeater, and gap filler applications. And actually, the SFN part is a standard feature. The GPS receiver is built in, and the SFN software is built in. They come with a 4-year warranty, as I mentioned. They all come with the Nautel style AUI and other cool IP stuff. Nautel Phone Home is being implemented, so these transmitters can actually be part of our network of proactive customer service. And yes, higher power transmitters are coming. That's probably the question I get most, Rob, when I travel and talk about the NT series. Is up until now it's been, when could you have a 1 kilowatt? Well, ta-da, here we are introducing that today. But even higher power levels are in the offing. And here's where we go and see whether we missed anything and people have questions. So we'll see here. Hey, so far it looks like we've gotten off scot-free. We must have covered it really well. My hat's off to you, Rob. We did a good job. I do not see any questions, but if you have questions, it's not too late. You can certainly go back and send us an email, send me an email, or sales@nautel.com, and we'll answer you Here's lots of sources for getting more information from Nautel. There's the Waves newsletter, which if you're not subscribed is a really good thing. Sign up for that. There's all of these webinars have been archived and are available online on the web, and you can download and watch them 24 hours a day for years and years in the past. And so there's a ton of information there. We have our YouTube page. We have our Nautel store. If you haven't used the RF toolkit to plot the coverage of your FM or TV station, you can do that there, or even your STL. We have our Facebook and LinkedIn pages. Please see us on the social media. And one other thing that's really, really cool is bear in mind that what you just did, what you just watched, has qualified you for half an SBE, our recertification credit, identified on a category one of the research schedule for SBE certifications. Nautel is a massive supporter of SBE, and we're very, very proud that SBE has seen fit to give people who watch these webinars a credit towards their certification. We're ready to help, and all of the Nautel customer service and sales people are at your beck and call for answering any questions that we can. For now, for Rob Edsall, I'm Chuck Kelly, thanking you so much for being a part of our webinar today, and please join us again. Bye-bye now.